Hello and welcome to the Zambumon Sar build video. I would like to begin thanking everyone, the community and friends, for the many years of support since Sar was first revealed. Let's start by checking what's included in the keyboard kit. An enclosure composed by a top piece, internal weight and bottom piece. A 4.75mm switch plate in either polycarbonate or brass. The WT98 SAR circuit board, a breakout USB-C daughter board and a JST cable. These last two components have already been pre-installed. A set of silicone rubber feet, as well as a set of urethane foam gasket strips that should be attached to the top and bottom pieces. 3 lighting pipes. These should come pre-installed. Do not try to remove them. They are very fragile and extremely easy to lose. You will also find a hardware kit. It includes the enclosure fixtures and the hot swap fasteners and spacers. We have also included a set of A-board stabies, and everything should be safely packed inside a custom carrying case. Here are some technical specs of the Zambumon Sar keyboard. It has an 8-degree slope, a 4.75mm isolated gasket mount fixed plate, and a hot swap PCB. We estimate that a full build should be around 2.65 kg for the polycarbonate plate configuration and 3.5 kg with the brass plate configuration. After checking that your Sar keyboard kit includes all of the mentioned hardware, you should begin by attaching the adhesive silicone rubber feet to the bottom piece and the urethane foam strips to the bottom and top pieces of the enclosure. This is also a great time to check that the hot swap PCB is in working order. Connect the main circuit board to the USB-C breakout daughter board, head over to the USB.tech app, authorize the device, and check on their tester that all keys trigger when pressed. I am now going to prepare the main circuit board and switch plate subassembly. For that task, a Torx T6 driver is needed. First, I'll fixture the countersunk M2x3 and the threaded spacers onto the plate. The hardware kit should contain at least 14 spacers and 14 countersunk fasteners. The purpose of these fixtures is to secure the switch plate and circuit board together. They also help with correct switch installation. As this is not a production unit, I could only scavenge about 6 of these spacers from other keyboards. That being said, ideally you should install all the spacers. Do not over-tighten these screws. Finger tight should be more than enough. Next, I'm going to tackle the stabilizer installation. For this task, grab a hex 1.5 driver. Sar uses 4 2-unit stabilizers and a single 7-unit one. I have prepared a set of stabies off camera. These have been lubricated using 205 grade 0 by filling the cavity of the slider using a syringe, and removing the excess from that process with a microfiber towel after emphatically exercising the stabilizer, until no more residue is found on the circuit board or the top of the stabilizer housing. When installing a stabilizer, it is extremely important to not over-tighten the fasteners. Finger tight is more than enough. Over-tightening will cause binding issues, especially on spacebars. So it's important that the stabilizer can adjust itself a little bit to the keycap installed onto them. The next step is to finish attaching the plate and circuit board together. We are going to need a Torx T6 driver, and the 14 M2x3 socket head fasteners. Check that all of the socket head fasteners have been installed, and then we'll move on to the mechanical switches installation. For this particular build, I will be reusing one of my favorite Franken switches, the Poor Man Nixis. The housings are Gateron milky tops and black bottoms. The stems, some 2018 retooled Cherry MX blacks. For the springs, I have chosen to go with the TX medium length 62 grams. And for lubrication, I have used 205 grade 0 for the stem and housing, and GPL 105 oil for the springs. These have been daily driven since 2020, and recently they were even aged more by simulating 1,000,000 presses on a switch breaking machine. For a safe switch installation, and to heavily reduce the chances of damaging a hot swap socket or the circuit board, make sure that the switch pins are fully straight, place one hand under the circuit board and provide support to the hot swap socket with one of your fingers, and install the switch fully perpendicular to the circuit board. Next, we will proceed with the enclosure assembly. Grab the bottom piece and the plate and circuit board subassembly. Lift about 60 to 90 degrees the subassembly and connect the main circuit board to the USB-C daughter board. Place the plate and circuit board subassembly onto the bottom piece. The subassembly will self-align with the urethane gasket strips. Grab the top piece and align it with the bottom. Sandwich the plate subassembly and flip everything upside down. Be very careful when doing this operation, especially if you are building the keyboard using a monolith plate. We will now fixture everything together. For that, we will need 8 M3x8 socket head fasteners and a Torx T10 driver. Loosely fixture everything together using a cross pattern. Then, do a second pass to finger tight everything using the same pattern. The goal is to make sure that everything is evenly secure with no loose or over-tightened fasteners. The last step of the assembly is the keycap installation. I have chosen a set of G&K Serica 2 designed by myself. For the escape key, however, I will be using a Latrialum Serica Artisan keycap. When installing the keycap set, pay attention to the stabilized keys and ensure that they are properly seated. And with that, the build is complete. Thank you very much for watching, and I will now leave you with a typing demonstration of the Zambumon Sar mechanical keyboard.